All right, so let's actually go through Cramer's rule. Instead of just setting it up, I actually solve it. All right, so the denominator for all three of them is going to be the same. So I only need to solve 4 determinants. So the determinant down here is just the coefficients. And they do need to be lined up. There's an implied plus 0b here, or minus 0b if you wish. So I have negative 6, 0, 1, that's the coefficient first. Then I have 6, 6, 1, and 0, negative 8, 1. Numerator, so I'm solving for the first term, since I had b listed first. I'm going to replace the first column with these numbers over here. So I have negative 8, negative 12, 0, and then 6, 6, 1, 0, negative 8, 1. So now it's just a matter of solving. You prefer repeating the first 2 columns? That works better for you? It seems like there was my recollection from a week ago was that that's the way you'd seen it done before.
What do you mean repeating the first 2 columns?
When solving the 3 by 3, writing out the first 2 columns again and coming diagonally.
I don't think so.
Going around the corner?
Oh, you're talking about that, yeah, when you explained that extra stuff, putting stuff to the side of the matrix, I'd never seen that before.
Okay, you had not. Okay, all right, I won't do that then. All right, so we have negative 6 times 6 times 1, so I have negative 36, plus 6 times negative 8 times 1, which is negative 48.
Yeah, I've never seen it this way either.
How have you solved 3 by 3s?
For determinants?
Yeah.
Where you like hide one row or hide one column.
Oh,
and
so
then,
you just,
and then do the bottom, and then you reduce it down to a 2 by 2, and then do the 2 by 2,
Okay.
basically.
So
this is if you got a faster way.
I find this faster, but
Yeah.
that's me.
I'm totally down for it.
Paul, do you have a preference?
No.
I'm not, my preference, no.
That's fine.
I'm just going to repeat the first 2 columns. And now typically when I'm doing it, I don't do that, but for people who are just starting out, they tend to find this helpful. And so now I'm just doing that column right there. So that's negative 36 plus, and then 6 times negative 8 times 1, negative 48, plus, and then it's that, and then 0 times 1, which is 0, minus. Going the other direction, 0 times 6 times 1 is 0. Negative 6 times negative 8 times 1 is positive 48. And then 6 times 0 times 1 is 0. Doing the fancy math here, let's see, that is negative 84 minus 48. 132. Negative 132. Questions to you? All right, let's do the first column then, or the numerator.
Where'd the numerator come from again? Sorry.
Numerator is going to look very much like the denominator, except for we're going to replace one of the columns with these numbers, because the denominator doesn't take that into account. So we got to do that somewhere.
So the numerator did.
Yeah. So in the numerator, you're going to replace whichever variable you're trying to find. Since I have b is listed as the first variable, in other words, these are all the coefficients of b, then I'm going to replace those coefficients with the constants.
Okay.
So negative 8, negative 12, 0, 6, 6, 1. So I get negative 48 plus 0. Plus 64. Plus negative 72. So this is negative 48 minus negative 8. And so we minus negative 8, yeah, that's right. So we get negative 40. And so B should be negative 40 over negative 132. Which reduces, what, negatives cancel out, and I got 20 over 66. Which is 10 over 33. And I can't remember what we had last time. We'll assume that's correct.
Sounds about right.
For B. For B.
Yeah, that's right.
Okay. So officially, so I have a current flowing across here of 10 33rds amperes going to the left, across here, going to the right, at 10 33rd amperes. To find C using Kramer's rule, the denominator is the same, negative 132. I don't need to redo it unless I wanted to just double check and make sure I did it right the first time and see if I got the same answer. But the numerator, since C I have listed as the second variable, I'm going to replace the second column. So this will be negative 6, 0, 1 in the first column, same as there. This is 0, negative 8, 1, and same as there. But it's the middle column that gets replaced, so negative 8, negative 12, 0. And doing the repeated column method. So we start out with that. So that's 72. Plus negative 8 times negative 8 times 1. It is 64. And then plus 0. Minus, going the other direction, I have 0, 0, and 0. $136 over negative 132. So C is negative 136 over 132, which would be, if that's 66, that's 68, negative 68, 66, negative 34, 33, 33rds, which seems somewhat familiar. The negative sign just means that the actual current flow is opposite the direction that we assigned over here. I said the current was flowing up, we got a negative, so the current is flowing down. So if I'm presenting the answer in terms of what is the current flowing across the 6 ohm resistor, I have two answers that are perfectly acceptable. I can say that the current flowing across the 6 ohm resistor, so I'm just writing I sub 6 ohm, is 34 33rds down, amperes, let's not forget units, down, or negative 34 33rds amperes up. Either one that I accept. All right, questions today?
So C was the middle one,
Yes.
and then because it's going from the positive, that counts as up. Is that what you're talking about?
Oh, the up bit.
So if it goes down and then to the right, that's, wait, up.
When I was defining my currents at the beginning, when I defined B, C, and D, I said C was the current flowing up.
Okay.
I didn't care whether it actually went up or not. If it is actually going up, I'm gonna end up with a positive value for C. If
Okay.
it's actually going down, I'm gonna end up with a negative value for C. I don't need to redo the problem.
But the way you have it, we ended up with a negative?
Yes, because I said it's going up when the current's actually flowing down.
Oh, okay. And the current's actually flowing down because that's the positive side of the terminal?
Because, not necessarily, in this particular case, I got, if you have hot wheels growing up,
Yeah.
did you have the track? And, but, I guess they usually come with it, maybe not. Did you have the spinner so that you could, the car can go through it and shoot the car around?
No, I know what they are, but I don't think I specifically had one.
Alright, basically, for those who, looks like Phil's what I'm talking about, you had some nods there, so no one else.
No, I had the track where you put it in and then like I guess you twist it and then it goes up and around.
Twist it.
Yeah.
Oh, twist the track. Yeah.
Well, you twist the little, I know what you're talking about, it's like a mechanism, and you just twist it and it like, I guess charges it up.
Oh,
And
winds
it's
it up.
just like- yeah, and then you put
Okay.
the little car in it and then it just.
We have batteries.
Batteries?
Anyway, so it's basically two wheels spinning like this. If you play baseball, then it's what they use for the automatic pitchers, pitching machines. But two wheels spinning like this, and the car goes through it, gets shot out, and if you've designed it right, or after some trial and error, the car has enough juice to go all the way around the track, come back, get to there, get shot through again. So if you imagine that this is like the wheels spinning like that, it's shooting water this way, shooting water that way, shooting water that way, I can pretty much look at that and go, yeah, it makes sense that the current's gonna be flowing like that. But I chose C to go up, because why not? It doesn't matter when you're setting up the equation, just so long as you're consistent. Now, so the current's going down like this. I know that if I put the thought into it, I go, yeah, I know the current's gonna flow this way because those are gonna overpower, basically they're just gonna shoot overpowering that. But I could have had, it is possible to have the battery going this way and the current still go that way in the middle.
Oh, okay, so current can actually flow from the negative terminal in physical reality.
Yeah,
Okay.
for the most part, this is a stupid design. But they are setting up a basis for solving more complex circuits. For you future electrical engineers. Not you. Everyone knows mechanical engineers are the cool ones, right?
No. Just kidding. I heard it's like one of the hardest to do, mechanical.
I got the degree, I did not take the professional engineers exam or the EIT.
Did you get a physics undergraduate too, or you did mechanical and switched to physics?
Yeah. All right, and then to find D, I already know the denominator. The numerator, it's gonna look a lot like the denominator, except because I have D listed as the third variable, I'm gonna replace the third column. So the first two, negative 6, 0, 1, 6, 6, 1, and then the third column will be negative 8, negative 12, 0. And doing the repeated column method, negative 6, 0, 1, 6, 6, 1. Now the method that Phil laid out earlier is the official method, or one of them. And also, you can actually start anywhere and work your way through it. So I have 0, minus 72. Plus 0, I guess plus negative 72, minus, going the other direction, negative 48, plus 72, plus 0. And so I get negative 72 minus 24, negative 96, so negative 96 over negative 132. Negative 48 over negative 61, no, 66. Negative 24 over, oh, the minus signs cancel out, so 24/33. We can do a quick check just to make sure it makes some sense. So I have current flowing down this way of 34/33 amperes, and now I have current flowing this way of 24/33 amperes. And so at this junction up here, I have 10 and 24 flowing in, so 34 flowing in, I have 34 flowing out. So something seems right.
We got a different D on Thursday, Wednesday, or Tuesday.
We had a different C,
We had a different D,
D, oh. What do we have then?
8/11s.
Oh. Could have taken it one step further.
Oh, all you gotta do is reduce it, my bad. Should've saw that.
May that be the worst mistake of the day. Now, I'm guessing a number of you are going to use your calculator to solve the system of equations. That's fine, just again, be aware that if you mistype something into the calculator, I won't see what the mistake is.
You're not gonna expect us to go through the handwritten method on the test though, right?
Not unless you want to. If this were math class, yes. If it is physics, let us use the tools that we're given. Although I'm surprised, usually on the test, I'm surprised at how few people actually end up using the calculator. Or they might use the calculator to check their answer, but which is a double-edged sword. How much time do you have to figure out where the minus sign got this? Where the zero got? Looks kind of like a 6. For some of you with dysgraphia, please be very careful when writing numbers. I'm about to erase this, and we're going to solve the exact same problem a different way.
This is what we were doing last week, right?
Yeah.
Okay.
Yeah, we didn't actually, from my understanding and memory, we didn't actually solve it using Cramer's rule. We just set it up and stopped.
Can you explain where the -8, negative 12, and 0 came from again?
You see where these two equations come from?
Yeah.
All right, so that simplifies down to these two. And then to put it into the proper format for Cramer's rule or solving with matrices, I need to
Yeah.
get the constants.
Yeah.
So, at least my exposure to what Mike Jones wrote up years ago about using the TI-80 whatevers. Using RREF, something like that.
Reduced row echelon form.
Sure.
What we tried to do on Tuesday that led us down a deep rabbit hole.
Yeah, I guess it is you doing matrices. Okay. I mean, the setup's the same. All right, so this is the one current per wire. I just went through Cramer's rule. There are algebraic methods because of your math background. I wasn't necessarily going to go through the algebra aspects of it. You should have, under old tests, I had more 252 complete solutions than for any other course. I've got a slew of these type problems where I solve it different ways for different tests, just for variety. So whatever you end up picking, just please pick a method of setting up the equations or solving it. Know how to do it. Don't mix and match, unless you know what you're doing. So now I'm going to get rid of this. All right, mesh analysis. You're basically doing one current per loop. I typically use left loop, right loop to pick from my two loops. I could use the entire loop. I have basically three choices here, three simple choices. I have left loop, right loop, and full loop. I'm picking two of them. And I just arbitrarily pick a direction. And so in this method, I'm just going to take the left loop and I'm going to go clockwise, and I'm just going to call that current. I'm going to call that E. And then I'll go to the right loop and I'll do the same thing. F. I have two unknowns. I need two equations. Both of them are going to be voltage equations. Now I need to do my voltage loops. I have a choice of three. I pick two of them. I can do right, I can do left, I can do the whole thing. If I was feeling particularly bored, I could do a figure eight. But you'll end up with some values that will just cancel out immediately with itself.
Are we solving for the same thing again?
Yeah,
or-
it's all the same thing. Just different technique. The biggest issue people have with this one is dealing with the middle resistor where I have two different currents going across it.
Is that 2 or 6 in the middle?
That's a 6 right there. Is that the one you're looking at?